regression and correlation. So we'll be looking at a topic which most students love, the easiest in quantitative methods. So when we're discussing regression and correlation, basically, we'll look at what is called linear regression. We'll also look at how to draw the scatter plots, how to identify which ones are the dependent and independent variables. We'll also look at how to come up with a regression equation, the coefficient of correlation, then also other things like the confidence intervals using regression. For your syllabus, they are not so much examined. So I'll just look at the relevant parts. And lastly, how to use the calculator. So when we're dealing with regression and correlation, these are some statistical techniques which we use when we're analyzing two variables. And so correlation looks at the direction of the linear relationship and the strength. Regression looks at the prediction equation. So in this syllabus, we have the easiest topic, which is also found in managerial economics. So we have relationships that exist. There is a positive relationship, which looks like this. Y is equal to what? A plus bx. There's also a negative relationship, which looks like this. Y is equal to what? A minus bx. So these relationships are illustrated by what we call a prediction equation. So B stands for the slope or the gradient. It is simply given by x, y over s, s, x, x. A is called the y-intercept. An intercept is simply a cutting point. So where it's cutting the y-axis, it's called the A. So A is what? The y-intercept. It is given by summation of y over n minus b summation of x over n. Okay. So we call this the y-intercept. Sometimes, so collectively, these ones are what make up the regression equation. Y is equal to a plus bx. Or other books would give you y is equal to what? bo plus b1 x. So we know that this is the y-intercept, and this is the slope. Now, the direction of the relationship and the strength can either be strong or weak. So if it's strong, the dots are very close to each other. So this is what? Epitomized by the letter R. R stands for the what? Coefficient of correlation.
Sorry, Mr. Collins.
Yes, sir.
So, you said A is the intercept and then B is the slope. What
Yeah.
about X and Y?
Those are the variables. Y is, X is an independent variable, Y is a dependent variable.
Okay, great. Thank you.
So coefficient of correlation, that is our R. So coefficient of correlation is simply given by xy, the sum of squares xy over the square root of xx times yy. These are simply variations in x and variations in y. So your R can either be a negative or your R can either be a positive. So if you have a negative relationship, it means it looks like a demand curve. It looks like this is downsloping. So what is the difference between these two? Both of them are upsloping, and both of them here are downsloping. So one is downsloping, but with a weak relationship. One is upsloping, one is strong if the dots are close to each other. So to measure the strength of the relationship, we call it the coefficient of what? Determination. Coefficient of determination. It is simply r squared. The answer we got above, we square it. R squared is simply r times r. So if we have 0.903 as our r, what does this mean? How do we interpret this? It means we have a positive relationship. And if we square that answer and we get r squared, when we square that one, maybe we get 0.816. What does that mean? It means 81.6% of y is affected by x. 81.6% of y is because of x. Let me take this just to your basic understanding. You may have sales and advertising, and you have a regression equation which is given by sales is got what? 10 plus 0.5a. So what is the significance of this what? Of this equation? So our intercept, our a is what? 10. So it means 10 is an autonomous figure. It means even without advertising our sales, because even with zero, when you put zero advertising, we still have a sale. Here where the advertising, we put zero. So meaning we still make a sale of 10 million without advertising. So our A is what? The intercept. It's an autonomous figure. Then our slope, B, is 0.5. This is our Y and our X. Because I said X is what? Independent variable. It doesn't depend. So advertising doesn't depend on sales. So an independent variable is a variable that doesn't depend on the app. And Y is what? Dependent variable. Sales depend on advertising. They vary with an input of advertising. So it's called a dependent variable. So for every 1 kwacha increase in our advertising, there'll be a 0.5 increase in the sales. So this equation is what we call the regression or the prediction equation. You're able to predict, for instance, if you are told that you had 10 million advertising that was given to you, how much sales you expect. Where there's advertising there, you're going to put what? At 10 million. So 0.5 times 10 million. I'm just giving an example. So this will be 10 plus what? Plus 5, which is 15. So you're going to have sales of 15 million if you're going to add advertising of 10 million. Therefore, regression is important for 3 things. Number 1, we're telling you the type of relationship, whether it's a positive relationship or it's a negative relationship, using R. R stands for the coefficient of what? Correlation. And the formula for R we said is sum of square xy over square root of sum of square xx times yy. What are these xx and yy? The variation in xx is simply given by what? Summation of x minus summation of x to the power 2 over n. And what is yy? It's the same thing, just put y's everywhere. Variation in y is simply summation of y squared minus summation of y to the power 2 over n. How about summation of xy? Xy is simply summation of xy minus summation of x times summation of y over our n. Don't worry, these formulas are all given to you. So regression helps you identify the type of relationship, whether it's a positive or it's a negative. And the regression will always range between -1 to +1. Can't get more than that. Then the second use of regression is to measure out the strength of the relationship. The strength of the relationship is given by our R squared, which is a coefficient of determination. So coefficient of determination is simply R times R. It measures the extent to which R affects, the extent to which Y affects, is affected by X. So if we found 0.9, it's a very strong relationship. It means 90% of the variation in Y is because of X. But if we found 0.4, it's moderate. From 30 to 40 to 50%, it's moderate. That means 40% of Y is because of what? X. How about if one found 0.1? It's a weak relationship. It means 10% of Y is because of X. Now, this is very vital, my friends, because sometimes if you're a marketer and you want to convince management and you have your R squared, which is 0.1, they will not give you the support that you need as the marketing department, because the impact of the advertising budget to your sales is marginal. It is insignificant. And finally, regression is used to what? For prediction. Predict the future. Using the prediction equation, y is equal to what? A plus bx. Are we following? Are we together so far?
Yes.
This is where you're going to survive. This is your easiest topic. This one is coming, like it or not. And we might even preempt. So I'm making a set of preemptive questions that the question that I think will come. All right. So I know there are people who are lazy studying, so I'll just give you 4 topics to identify. But of course, don't specialize. So the number 1 easiest topic is what? Regression. Number 1 is regression. Number 2 topic that you should identify is ANOVA, which I'll teach in the evening. Number 3 topic is hypothesis testing. Number 4 is statistics, the mean mode. That one is number 4 because it's bulky. I don't like it because it takes a lot of your time. Most of you think it's easy, but by the time you're identifying it, you'd have wasted a lot of time. This one only takes a few minutes. Then I can now allow you to go to probability. Because I know most of you fear probability. Of course, sometimes probability comes in 3 questions or 2 questions. It's spread so that he leaves you with no option. All right, so I'll teach all this. But this is the easiest topic. Now, we're given this. We are being asked, number 1, plot, a scatter plot. Number 2, find y on x. Just telling you to find the regression equation. Number 3, find y if x is what? If x is 10. And number D, find r and r squared. And interpret. That's all. 25 marks. So I want to make it harder for you to do what? To fail than to pass, unless you just want the other way. So x, y. So 1, 2, 3, 4, and what? 5. You have 1, 1, 2, 2, and 4. So what is our xy here? What is our x squared? And what is our y squared? Let's do together, x, y. Okay, let's do the sketching first together. What do I do now? I can sketch this first of all before I complete the table. We sketch from our grade 12 knowledge. How do we sketch? Using our x or y plane. Our y is always here. Our x is here. So we have 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here you don't even need to draw the line, just a scatter plot. 1, 1, you put your x there. 2, 1, so 2, 1, you put x there. 3, 2, 3, 2, you put x there. 4, 2, 4, 2, you put x there. 5, 4, 5, then 4 there. So you just say, it's your scatter plot. 3 marks. 3 marks for that. From this scatter plot, we can even tell it is upsloping. You see, it's going this up direction, and the dots are close to each other, meaning it has a strong relationship. All right, then we can even complete this table. XY, it is 1, 2, 6, 8, and 20. X squared, 1, 4, 9, 16, and 25. And y squared, 1, 1, 4, 4, and what? 16. So let's get the total. This is a summation of x. What do we get? Summation of x is 15. Summation of y is what? 10. Summation of xy is what? 87. Summation of x squared, 55. And summation of y squared, 26. Our n, how many pairs we have? Or how many rows we have? Our n is 5. Anyone behind so far with what has been done? You can ask. Are we clear? All right. So we are clear.
Yes.
We now go to itemize our summary. So our summation of x is 15. Summation of y. Summation of xy. Summation of x squared. Summation of y squared. So it's 26. This was 55. This was 37. And this was 10. And our n was 5. All right, so this being the summary, we can also do the sum of square xx. Summation of x squared minus summation of x to the power 2 over n. So here we're going to put what? X squared is 55. Summation of x is 15 to the power 2 over 5. Okay. So we're going to get 55 minus what? 45, which is 10. Then summation of yy Y is throughout. So the big one, y squared is what? 26 minus 10 squared over 5. So this would be 26. 100 over 5 is 20. Minus 20 is equal to 6. And we go to sum of square xy, which is summation of xy minus summation of x, summation of y over n. So we have xy is what? It's 7 minus 15 times what? 10 over 5. So this will be 37 minus 30, which is equal to 7. Right. So can even do some preliminary calculation. The slope is xy over what? Xx. So what do we have there? 7 over 10, which is 0. What? 0.7. And our A is summation of y over n minus a b we just found, summation of x over n. So summation of y is what? 10, our n is 5, that is already a 2. And here I have 0.7, which we just calculated. So if that one is wrong, it also makes your what? Your A wrong. So here we're going to have 2 minus, this is 3 times, this is 2.1. For 2.1, we get negative 0.1. So this is what we call our intercept. So our A is equal to that. All right, we also saw our R, which was simply given by summation of, it's almost close to B over the square root of xx times yy. So this would be what? 7 over square root of what? 10 times 6. So when you compute that, you get 0.903. And when you square that, you're simply going to get our R squared, 0.903, the power 2 to give you 0.81666. All right. So we have our A, we just computed it. It is what? Negative 0.1. We have our B, we just computed it. It is 0.7. We have our R, we just computed it, 0.903. We have our R squared, just computed it, is 0.8167. So part A, we're asked to plot, which we did, we plotted. Part B, they're asking us to find the regression equation y is equal to a plus bx. Now we've already found our A. We just substitute in this regression equation. Our A is what? Negative 0.1. Our B is 0.7. Where there's x, you put the x there. So this is what? Our regression equation, 5 marks. At C, they're asking us to predict y when x is equal to 10. So we just go into the equation and replace. Where there's what? X, we put what? 10. So when we put a 10 there, we're simply going to have negative 0.1 plus 7, which gives us 6.9. So this is our predicted value. Then part D, they asked us to find our R and R squared. So we know R, the formula, we've already done that. We don't need to redo the calculations. The interesting thing with this topic is that the calculator gives you leakage. If you punch everything, it gives you all these values. So here we found 0.903. And what is interpretation? Since it's a positive, you can say X and Y are positively related. That's a comment. If it was negative, X and Y are negatively related or inversely related. For negative, same as inverse. Then our R squared was 0.1867. What does this mean? It simply means 81.67% of what? Of Y is influenced by X. And this one comes in two questions, unfortunately. It's like probability, he brings correlation alone and determination alone. So this is a very easy topic. Okay.
Mr. Collins, I'm a little bit behind on how you found the values for A and B on the previous slide.
How do you define the values of A and B? So you first needed to understand where we found our XX. Our XX was what? 10. Our YY was what? 6. And our XY was 7. So the formula for B is what? XY over XX. So we get XY, our answer was what? 7. You put a 7 there. XX was what? 10. You put a 10 there. So 7 divided by 10, it's 0.7. That is your B. Then our A, its formula is summation of Y over N minus B, summation of X over N. We know our N is 5. Summation of Y was what? 10. You put a 10 there. Our N is 5. The B is simply the answer we just got here. You put it here. So if it's wrong, like I said, it's also wrong here. Then summation of X is 15, and our N is what? Our N is 5. So 10 over 5 is 2. 15 over 5 is 3. 3 times 0.7 is 2.1. So this is how we found our A. Mwasange ifibidi, just replace them in the function. So this is our prediction function. If our B was negative, the sign you should put here is negative. Since our B is positive, so A is negative 0.1, and our B is 0.7. Is that clear?
It's clear. Yes, I was behind on the just on the formula.
Okay. Any other question? Any other questions? It looks very easy, but requires practice. Any other questions, please? Is it clear? This one is a very short topic. We're pregnant with max. So I will maybe take you through an exam question so that you can see how it comes. And I'll give you that as homework. Comes in 2 questions. This is the previous paper, 2022 November, the previous one. Show the last question. I've memorized the way they come. Okay, the following data in millions. So look, he brings 2 questions. Okay. No, he combined with ANOVA last time. Okay. So look at how interesting it is. He gives you the values of payroll and the number of wins. And he further on spoon feeds you by giving you the value of B and the value of A. Already you're able to tell the regression equation. Who wants to try? What becomes the regression equation? Y is equal to what?
Y is equal to 67.5 plus 0.125x.
Yes. So identify the linear equation. This is very easy. 67.5 plus what? 0.125x. And now predict the wins, given that he invested 90 million. So 90 million obviously is what? The X there. So here you put 90 million. And predict this one. So we just put Y is equal to what? 67.5. And here you put 90. Of course, your answer should be in millions. You see, you get your free marks there. Here there was proper spoon feeding. It makes us irrelevant. We need us at this point. That's why he's saying his classes are enough for you to understand. All right, then the other part, he doesn't give A, B, and C. So he does this. He gives you the number of hours against exam score. Then he even finds the totals for you. Okay, summation of x squared, summation of x, summation of xy. Now this makes me very irrelevant because what I'm teaching is even tougher than this. So they asked to find the correlation in terms of hours. So now that's why you need to find that value. Now, summation of what? Xy over summation of what? Xx times YY. Now, I've summarized your formula because in your books, he'll give you the same formula, except that we know that XX is just what? X is throughout and YY is Y is throughout. So look, who can remember what is XX? Let's do some memory. XX is what? Summation of X to the power 2 minus what? Summation of X.
Summation of x to the power 2 over n.
Okay, then YY will be what?
Summation of y squared
Mm-hmm.
is summation of y to the power 2 over n.
N, excellent. And XY?
Xy is the summation of xy minus summation of x multiplied by summation of y over n.
I'm so proud of you. You're really putting extra effort. Then B is what?
Summation of xy over summation of xx.
Good. Excellent. So now look at this. In the books, instead of summarizing like this, he will give it like it's the same as summation of what? X and a summation of x squared over n. No, it's xy on top. So in the book, if it comes like this, summation of xy minus summation of x, summation of y over n over summation of x squared minus summation of x to the power 2 over n. It's the same thing because this is xx, right? And this is xy. Or other books will just bring it as follows: n, x, y. They just bring the n in front. X and y divided by n x squared minus x to the power 2. This is all the same formula. Mamonate,
Yes.
are you agreeing?
Yes.
Then even for R, I've simplified R as follows. So if there's one thing that I do, I go through your notes so that I don't go off what he's giving you. Okay, so I don't want you to get confused. X in this one is the same as what? The same top part, they'll bring it like that, except that it looks ugly when it's brought inside. It looks a little bit complex, but it's the same thing. And then panshapa, palawachi square root chikulu. Then down there, we're going to have what? These two. Here we have the variation in x, so it will be summation of x squared minus summation of x to the power 2 over n. And here we have summation of y squared minus summation of y to the power 2 over n. Then all the n's will just come in front. This will be that times square root of n summation of y squared minus summation of y to the power 2. Are you getting what I'm trying to say? These things are just fused in, all right, to make them a little bit complex, but it's the same thing. All right, unless you choose not to listen. So taking back the previous question.
Let us go back to the exam question. The second one that you showed us.
What is coming? There's a times here. So this is the summation of xx times summation of yy. The summation of xx is summation of yy. If you bring the n in front, it's n that, but you use this close brackets here, times, you continue, n y squared minus y to the power 2. It's the same thing. So when you go to the exam question, after he's spoon-fed you with this, the only thing you need to get from this table is the number of pairs, your n. Right? So this is 1, 2, 3, 4, 5, 6. So n is 6. It is also there in the question. I'm sure they mentioned what? 6 students. That is your n. So n hasn't been listed there, so you put n there, which is 6. Then they ask you, calculate the correlation of coefficient. Correlation coefficient, they're asking you to find R. Okay? Then they ask you.
Is it R adjust or R squared? Or R squared is determination?
Determination, yes.
Okay.
R is correlation of coefficient, yes. All right? Then test. In fact, this question is in our Bible. Okay? 6 students studied. So you will do or to go through the QM Bible. So 6 students, just type the same questions, just list them from there. You see here, I've just typed 6 students, exam score and hours. All right. Then those down there, you find x, y, x, relation of coefficient. I've told you this formula is just the same as x, and y, which I was doing. Then when you do that, I'll teach you during the physical classes how to use a calculator. This will just be for formality's sake. Then you find your R. This is your 2 marks. Then you test at 5%. Now this is under hypothesis testing. I'll teach it later on. And he gives you this one. This man even gives you the T-score. This one feeds you the T-score. Look at the question here. This same question here. The T-score is given you because he knows you guys are very lazy. This answer here, which is this answer. And he asks you, test it. Then you go through this whole procedure. So we're going to make the marking key. All right, so that's the good news I have for you. What's her name again? Mwanza. All right.
Thank you.
So don't worry. I will demystify most of this. But this week I'm finishing the whole syllabus so that I start revising the next week. So I'll start from so these are the topics that I'll concentrate on. So I'm done with regression. So in the evening I'll do ANOVA, then I'm done. All right. Any questions?